Today we're going to cover a concept called service objects, and this is a new concept that not a ton of people, not a ton of boot camps will cover, but it's conceptually more difficult to understand than it is to implement. So up to this point, we've been creating a lot of CRUD apps that just, I can create a manufacturer and I can log in, and a manufacturer has many products, or like a beer has many ratings and a rating belongs to a beer and things like that. That's all fantastic, but that's at the that's just the core functionality of most applications, right? Like when you go to like Amazon's a giant CRUD app, right? I'm a user, a user has many purchases or orders, or a user has many orders, an order has many items and things like that. That's the basis of Amazon. But as Amazon grew, they build more and more business things into their application, right? It's like people who, when I click on this item, people who also bought this item looked at these particular things. So it makes your shopping experience a little better. Oh, I think I might need that. So there's more underneath the hood than just a basic CRUD app. I won't talk about that. There's other things that you might do when you're CRUDing stuff to a database. So like one of them might involve, like, if you want to keep track of like how many people bought certain items on certain days, you want to keep metrics of that. That might be happening in the background whenever a purchase is made on like Black Friday or something like that. If you need to keep like an inventory count so that you're not like sold out and people can keep buying things, and you say it's going to be there in 2 days, but it's not. These are all like these different kind of calculations that are happening in the background.
You happened to Warby Parker, like when they first started, it's several thousands, but they didn't have somebody who was tracking their inventory.
Exactly, right? Yeah. So it's kind of like I keep CRUDing new things, but I'm not keeping track of the inventory I actually have in my warehouse. That might be something that's happening in the background. Or, there's things like if you're triggering informational or confirmation emails, that's not necessarily a CRUD thing, but that's something else that's happening in the background during your CRUD. If you are like, whenever I create an order on eBay.com, I have to send a request out to PayPal because PayPal handles all the payment processing. So these are things that are all happening at the same time as just basic CRUD functionality. So that you think of any like major website, and there's more than just CRUD happening at one time. When you click that button, there's like 4 or 5 things, maybe 15 things happening in the background that you don't know about. Think about Target.com. You sign in, you press like a purchase. At the core of it, you're saying this purchase is being created. It belongs to this particular user, but at the same time, they're processing your credit card. They're keeping track of all of their they're probably sending like a receipt or report to their business place to keep track of like taxes and all of that kind of stuff. They're keeping track of inventory. They're sending something off to shipping. Shipping has to send off a whole bunch of other things. Like one CRUD action is just more than just that CRUD action, is what I'm trying to say. So there's like a limitless number of things that are happening in the background, but hopefully that gives kind of you a sense of the complexity we need to deal with on like a fairly regular basis. So as a refresher, Rails is an MVC framework. So MVC image. What does MVC stand for? And can you explain it to me? This will most likely be a technical question on some of your interviews. So I'm going to pick on Alex. Can you explain MVC to me? Because I saw you smile.
Yeah, I remember talking about it, but I'm terrible.
Okay, let's give it a shot. Let's see what we've got.
No, I'm not gonna try it.
Okay, John, Taylor, please, you volunteer.
Usually we talk about each component, like what
yeah. Tell me what MVC stands for. This is fine. I'm just gonna put it up here. Just tell me what MVC stands for, and tell me what each layer does.
Yeah. So the controller is sort of like the guy in the room, like on the shots. He's not doing any interpretation. He's just like passing tasks from the user. So you've got like the boss, like the user, the web from the web request in this case.
Okay.
That's like saying, hey, I want this to happen. And the controller's like, okay, so we got to channel it to either view or model. And model is what is like connecting information to the database.
Okay.
And, storing information, pulling information from the database, whatever it is.
Okay.
and then that sends it back to the controller, and the controller's like, okay, so I've got this new data, and how do I tell the boss what they've actually done, and how do I show them? And the controller can't do it, so it has to talk to View. View is like the HTML and CSS and like all that stuff that actually shows what that process did, and then sends it back to the controller.
That's pretty good, actually. I'm not sure what else there is to say. MVC stands for, the answer's right. So MVC stands for Model View Controller. It's a way that like modern web frameworks have organized their code. There's 3 different layers. There's the controller, which is more or less the brains of the operation, like Taylor said. So anytime anyone makes any sort of request, you click on this button, you submit this form, it goes to the controller first because it's kind of like a routing system. Like I go to the phone book and I say like, okay, where do I go? Like if the phone book was like, this is a bad example. It's the brains of the operation. Whenever I click on anything, fill out a form, press enter, it shows up in the controller first. And then once it gets to the controller, it's like, where do you need to go next? Do you need to make any sort of database calls? If you do, hit the model up. The model is the thing that's going to talk to the database and read and write information into your database. From there, comes back up to the controller. And it's like, okay, now I have all of the information from the database. I need to present something out to the boss. You know, the boss needs to see this out on the page. So that gets passed down into the view. So it's kind of like if you were to think of this as like a form letter, so to speak, like you get those giant form letters in the mail, like a credit card offers, right? Credit card offers, you get those in the mail, and it says, "Dear," whatever your first name is. So you can kind of think of it as, okay, I'm a controller. My boss is telling me I need to send out mail to all of these people who don't have credit cards with us, but we have their information. Great. Let's make a request into the database to get all those records out. And then once we have it in here, we're going to pass it into this giant template where we're just going to interpolate the first name, and it's going to go in there.
Yeah, let me try this out for a second. Have you guys seen The Office, the movie?
Yeah.
Okay, so what do you guys think of Milton being like the model, the engineer, like thick glasses, like doing like cranking off the work? Oh yeah, sorry, Office Space. And then Lumberg is the controller. He's like brainless, like he doesn't, but he's like the one who's actually in charge and like telling people what to do. And then you've got Peter, who is the TPS report, like he's putting it in the right format to send the Lumberg. Does that make sense? Yeah. Right. Here we go.
I've never watched Office Space, so it doesn't make
it.
Oh, dude, you got to do it this weekend, man. It's like homework. It is such an awesome movie.
It's a classic.
Hey, Peter, man.
Hey, Peter, man. Check out Channel 12.
All right. So we talked about things that are happening in the background, some business rules, right? If you want to create an audit log, if you want to create if you want to charge a credit card in the background, if you want to tell the order system to process this and the shipping system, where do you think that's going to fit inside of here? Like right now we have an MVC framework. I don't think it's definitely not going to show up in the views because views just take care of what shows out to the screen. In terms of business logic, that means it has to be split somewhere between the model and the controller. Again, the views only take care of what's supposed to show up on the screen. The view should just take care of some very basic if-else logic, like if the user's logged in, display this, otherwise display something else, but it should do no heavy lifting.
Why can't it go directly into a model?
What's that?
Why are you saying it can't just...
I'm saying it can't go inside the view, which means that has to be split between either the controller or the model. So very early adopters of the Rails framework believe that the business logic ought to live inside the controller, and that makes some sense because it's kind of like all the brains of the operation needs to keep track of all these different things. But the problem with that approach, at this point, when you throw everything inside the model, inside the controller, it's called fat controllers and skinny models, meaning like the controller is real fat. There's like 600, 700 lines of code going on inside the controller, and the model's real skinny. There's not much going on in there. But if you look inside, the issue is that like I said, your controllers get really, really big. So for one single action, like when I create an order, it might be like, first create the order in the database, then charge the customer, then notify shipping, then ship it out, then like update your inventory. Like you can imagine that could be like 200, 300 lines of code for like one single action. And when I say something broke inside of create order, it's like, oh crap, I have to look at 300 lines of code to figure out what happened. So as a response to that, basically what they did was they reversed it. They threw everything inside the model and then slimmed down the controllers a bunch. So you had fat models and skinny controllers.
But still kept it in the same line of code. I mean,
they just moved it from from one place, like they moved it from the controller into the model, but that kind of keeps the same thing. It's like one thing is going to be real fat and one thing is going to be real skinny. So instead of like having like 2,000 line controllers, they had like 4,000 line models, and so that would be like kind of crappy. So the other issue with having like controllers and models with so many lines of code is that one particular class knows a ton about some other class. And you can kind of think of it as like, based on what I know about the military and based on what you all have told me, each person in the military has a very, very specific task. And the whole organization works well because you are good at that task. Is that accurate? Like you don't like overstep your bounds in terms of like what work you're supposed to do. Is it? I don't know if that's accurate or not accurate.
Sure. We'll
go with that, right?
Okay.
If an organization goes well based off of like this person is supposed to do X, Y, Z, and this person is supposed to do A, B, C, you don't want the first person saying, I know all about your job and I'm going to tell you exactly, I'm going to micromanage you. And that's what's kind of happening here with your models and controllers when you have so much stuff. Like the model, like let's say I wanted to create an order. That means the model, and like I had to do the audit trail and the charging of the credit card and everything like that. That means from this model, I have access to all of the like audit trails. I have access to all the credit card, all the credit card information. I have access to all the, updating the warehouse inventory and things of that nature. And the problem with that is that there's one single point of failure, and you don't want to have one single point of failure. So that this is a concept called coupling, meaning that if I go inside your model and I see that you have access to 15 other models, I was like, okay, this is one single point of failure. Your code is very coupled, meaning if something blows up inside that one model, it blows up in 15 other classes as well. You don't want that. So what these people decided to do, let me first clone down what we have for today. We're going to be dealing with something called the business catalog. So I'm going to clone that down.
So like instead of making something as like shopping cart, it's like add shopping cart, and then the next model is delete from shopping cart.
Kind of. So basically what you have here is you can kind of see Rails 4.0 did not have all of these things inside of here. They didn't have something specifically for, or let's put it this way. Remember when we were writing Sinatra, we threw everything all in one giant file? We had like the get, and then we could connect with the database there and write all the routes and write all the logic and stuff like that. But then we got into Rails and we saw all of these small folders. Like if we wanted to do anything with controllers, there's a specific folder for that. If we wanted to do something with channel to create like a chatting app, there's a folder for that. If you wanted to do something with email, there's a folder for that. Essentially what we're going to end up doing is we're going to create, instead of having just the controller take care of everything or just the model take care of everything, we're going to create an entirely new folder called services. And this is the concept of a service object. It's an object that's going to basically combine our controller actions and connect to the database and just take care of one thing. Does that kind of make sense? It's instead of just throwing everything inside of the model and the controller, I'm going to separate out into like another layer called a service object. So let's kind of see what we have here to get started. So I'm going to bundle install.
You would devise via service object?
Device is not a service object in a strict sense. A service object is something that handles extra business logic outside of basic CRUD. Devise, I guess you could technically consider it devise like it does a service for you, right? It allows you the functionality to log in and log out effectively. All right, so I've bundle installed. I've YOLO'd just to save on some time. Drop, create, migrate, and seed, and let's load up the server. Let's see what we've got. All right, so welcome to the home page. Let's create a user real quick, register. Sure, I'll use Kara at Kara Codes, and I think the email and password is 123123. So I'll sign up here. Password is too short. God, 123123. Sign up. All right, let's take a look at our resources just so we're familiar with what we've got. So I go to my routes first. Looks like I have some manufacturers and I have some products.
Where do you save the routes? Where is that?
So it's under config,
Config.
and then routes. The way that I got to it super fast is a built-in into Atom and into Sublime. I hold down Command and I press T, and this opens up. This gives me access to every single file. So if I wanted to go to like a products controller, I can just do that.
Yeah, you did it on the video. And I didn't.
Yeah. So it's Command T.
Okay.
Command T.
What does that say?
I don't know. I have no idea. It's just what they use, I guess. So I have a manufacturer and a product. This is that nested CRUD we've been working with for the past week and a half. So let's take a look at the manufacturer's controller. And maybe we'll take a look at the products controller as well. Do we have any seeds? We don't. Instead of spending time on this, we'll deal with that later. Let's take a look at one of the let's take a look at this destroy action that we have down here. Now, we've added a few things in here. This is meant to mimic what might happen inside of a, this is meant to mimic what may happen inside of like an actual business, right? So let's say I want to, like a manufacturer has stopped selling a product. I want to delete that product off of my website. So first things first, if I wanted to destroy it, this is the CRUD action for destroy. I'm going to find the product. I'm going to destroy the product, and then I'm going to create an event, or just kind of like an audit log. This is meant to mimic an audit log. I'm going to create an event that basically says this person created this particular type of event, like a deleted product, and these are the details of the things that it did. It's meant to create an audit trail so that in case anyone says, hey, what happened to my, my Michelin tires, or like this particular model of Michelin tires? Actually, we deleted it. We can look who deleted it and what the details were as well. This is not like a hard and fast rule for everything. This is just meant as a demo of what could be created. So you can kind of see this controller is this action's very small. I'm just destroying, but I'm also creating an event. So I have a little bit of coupled code here. This products controller knows about the event class, which is okay, but we might want to move it into someplace else. So using the concept of service objects, and this is found in like other languages such as like Java has a lot of this. Inside of services, we're going to create a new file. We're going to call this destroyproduct.rb. Now, when I'm just going to create a basic class to get you started. Now, a service object is in charge of one service. So when the way that this is named, like the way the class is named, should be very, very indicative of what's actually going on. So when I look here, it says destroy product. What do you think this class is going to do? It's going to destroy a product. And there's two public methods I should be able to use. One of them is .new, and then is .call. So if I were to call it somewhere else, it's like destroy product.new. It takes in some sort of parameters that we will get into in just a second. And then at the end of it, I'm just going to do d.call. And then this kind of goes across the board. So if I wanted to email all my users, to sign up or something, I might create a service object, a class that says email unsigned up users or something like that. And when I want to call it, I just do .new with whatever parameters it needs, and then .call to execute.
And so like keeping track of all these assignments like D, right? D.call.
Mm-hmm.
It's like you would just be using Command T to like search through. Or like what if you I mean, obviously you're gonna have a ton of files, right? You have to remember that D.call was destroyed at.
I'm not exactly sure what you're asking, but I have an idea. Why don't we continue on with this, and then you can kind of keep that thought in mind, and then ask me if the next section does not help out.
Okay.
So again, we have two classes here. We have this controller. It does this destroys the product and creates an event. Now, I'm not a big fan of having one action take care of two different things. I also don't particularly like this controller having direct access into the event table inside the database. You want to protect yourself a little bit. So I've created a service object. The service object is called destroy product. And when I read these class names, when I read these file names, I should know immediately what it's going to do. Like when I read destroy product, what do you think it does? It's going to destroy a product. Another thing that you'll notice is that this is a plain old Ruby object, or what's called a PORO, plain old Ruby object. This doesn't inherit from anything. It doesn't have access to active record. It doesn't, if you take a look up here, products controller inherits from application controller. Application controller inherits from action controller base. Or if you take a look at the models, an event inherits from application record inherits from active record base. If you take a look at my destroy product, it's a plain old Ruby object. It doesn't inherit from anything. So nothing else depends on it. It exists entirely in its own space. It doesn't have access to anything else. It's just kind of isolated in its own little box. So I'm going to copy over some more code, and we will kind of see what we've got. So I've got a plain old Ruby object. When I initialize this particular service object, it's going to take in 3 arguments: the current user, the product ID, and the manufacturer. Basically everything that you need in order to create an event. And then finally, I'm going to take some of this code from here and place it in. So again, the service object is essentially doing the same thing as this products controller, because it exists in a vacuum by itself. It's only going to be called, it only knows about the things that you pass in and only executes the things that you want it to. Based on products controller, if I have this event here, I'm able to connect straight from my products controller directly into my events database table, and that's not essentially something I really want to do. So I'm going to take some of the code out of the controller and instead shove it inside the destroy product service object instead. You can kind of see the things I'm passing into destroy product are the exact same things that it needs in order to create an event. So all I'm doing is I'm moving the code from one area into another. So when I do destroy product.call, it's going to destroy the product first and then create the event. And then finally, for this whole thing, I'm going to get rid of this and just put this in there. I haven't done anything like crazy. I just moved all the code from one controller into the service object. And then from here, whenever I'm actually destroying something, I'm going to say service equals this new service object and pass in all the things that it needs. You can kind of see that it needs a current user when you create an event. It needs an ID of the product that you're deleting, and it needs the manufacturer as well. And I'm passing all of that in directly into my destroy product. Because this exists inside of a vacuum, it only needs to know about the things that it needs for this call method. So I create the new service object, I instantiate it here, and then I just do service.call. And then that's what's happening inside of the destroy. So instead of having all the lines of code that I used to have, I'm saying, here, destroy product, here's all the things that you need, and then when I do .call, destroy the product, and then create the event. I don't know if that was kind of where you were going with this, Taylor. Okay. So we have some tests kind of to get people started. So we'll just run those tests just to make sure that everything still works. Let's see what the tests look like. Products controller spec. If we go down to where's delete or destroy.
So the file is automatically added into your with your helper. So there is required in the top of your file.
You're saying
like the
this,
class was automatically like that. The destroy products.rb was automatically
added. Yeah, it's somewhere inside of this config initializers. One of these files somewhere basically says whenever even if I add a new folder and like a new if I add a new folder with any sort of files is required in every single file, so I have access to it directly. I don't have to do require relative at the top anymore. That's an example of like that convention over configuration thing that I keep talking about with Rails. It's like it's convention to require all the files together. So instead of setting that all up, I'm going to assume that you want that, and that's something that Rails gives you that's built in. Otherwise, you'd have to do like a require relative up top here, and then that could get quite hairy very quickly. So when I look at this delete destroy RSpec, it does three things when I destroy it. One, it destroys the selected product. It redirects the page, and it creates an event record. And that event record includes the details of everything that we expect. So again, I haven't changed this controller spec, and I've moved the code from everything from here inside the controller into the service object. And if all goes well, this test should still pass. Like the functionality should remain the same. This is why we do test-driven development. So we test everything ahead of time, and whatever code that we change, as long as it doesn't break the test, we know it's not going to break our code. We're going to do bundle exec rspec, and I'm just going to, I'll just run all of it. Why not? Why is this taking so long? Okay. All right, so we have 55 examples and 0 failures, so all of our codes still works. But since we have our own individual service object here, we are also going to have to create its corresponding spec file. So you can kind of see I have a spec folder for controllers, for routing, and for support. Now I'm going to create an entirely new folder for services. Every single file that you create must have its corresponding spec file. So I'm going to do destroy product spec.rb. And essentially what I'm going to do is copy over a whole bunch of code over from the products controller spec put it inside of here. So that's kind of what we've got right here. So I'm going to I created my own spec for this destroy product service object. And when I call it, it's going to destroy the selected product. So if I run the specs one more time, this should all pass. Did I mess something up? Let's take a look. Line 11. Yeah, it blows up. It says destroy product call destroys the selected product. Expect delete destroy params. Okay. And this is because I basically copied it directly over from the products controller spec. Destroys the selected product. Let's view these side by side real quick. Yep. Yeah, so you can see I have this directly copied over from the controller spec. This particular service object doesn't have access to all these built-in controller methods like the get and the post and the delete and all that kind of stuff. So instead of doing that, we're going to change our code a little bit just to match up with what is available to the service object. So probably don't need params anymore. We don't need that. Let's see if this works. And that passes. So again, I copied over all the code directly from the products controller spec and just dropped it in here. I just had to change a little bit of the syntax because I don't have access to the delete method inside of this service object anymore. And then I can just get rid of this. This goes away. Now I'm just going to grab all of this. These last two tests, remove them from here, and then just dump them in here instead. Probably don't need all of this.
It's like you're just doubling your work right now.
What's that?
It's like you're just doubling your work by having to test this module separately.
Not necessarily. Yeah, not necessarily. Let me 1 second. Let me just finish this, and then I can answer that question. So you're saying right now I'm just doubling the amount of work that I have to do.
You test the other one deletes, and now you got to test that your new object deletes.
I actually don't. So if you can kind of see, I've removed all the tests from the controller, and I've just placed it instead inside the service object.
Oh, so only does redirects back to the list.
Mm-hmm. Because if you take a look inside this products controller actually only it doesn't really do anything. It passes all of its stuff off to another person, this destroy product, and then it redirects. So yes, I do need to test that the controller redirects because that's its main job. But basically what this destroy function is doing is I'm passing it off to somebody else. And since I'm passing it off to somebody else, I need to make sure that somebody else is going to do that work for me. Let's see. Kind of like when you are, so there inside of software, people have been wondering about what does an individual contributor look like and what does a like a manager look like. So the term individual contributor inside of software refers to like a person who writes code. So individual contributor is generally speaking just an engineer, like a junior level engineer up to senior level engineer. Those are people who write code. So if you write code and you like all you do is kind of like take the stories from the backlog and then you do the story and you write the code and the code base is written by you, then you are an individual contributor. As an individual contributor, like you are managed by a manager, either a software engineering manager, a senior software engineering manager, or something like that. And those people set expectations for you. It's like, here's your professional milestone. Like you have to read this book and do this presentation, and then you can get promoted to like senior engineer 1 or something like that. They're in charge of your progression, but they are also in charge of like reporting back up to the product managers so that they don't bother you directly. If you are the type of person who hates dealing with other people, like, and you want other people to like, you only want to deal with just one person rather than all the business people coming towards you, that's your manager's job. They're there to protect you from like the business marketing people saying, I want this done right now. Like, this must be done correctly. And you're like, actually, no, it doesn't have to be done right now. We'll do it next week when we have time. You know, they're there to protect you so that your job is just to write code. And similarly, that's kind of what's happening here in this service object. You can kind of think of the service object as an individual contributor. Like, it's supposed to do one thing. Your job as an individual contributor in an organization is to write code. That's all you're supposed to be doing. Your manager can be seen as like this products controller, where it's like, hey, when you tell me to do this, I will actually, when the product team or marketing or business tells me that we have to build this thing, no problem. I'll pass it off to one of my individual contributors to actually write that code. And then afterwards, I will bring back the results and say, like, my team did this, so that this person never has to deal with like the outside business requests. Does that help out a little bit?
Yeah.
Kind of? Okay.
Is there a reason you use classes instead of a module?
So this class, are you saying like, why do I have a class product, destroy product rather than a module?
Yeah.
I need to initialize it with certain things. Kind of like if you were an individual contributor inside of an organization, you need to know certain things in order to write your story, right? So I'm saying, here's all the things that you need to get started. And then when I do .call, it's you creating the code to make something happen.
I was just saying, like, or a drive function instead of a module. You just pass everything. I mean,
this is just more of like an organization. I have more flexibility when I have a Ruby class than with a Ruby module. Okay. All right, so if you take a look inside of the spec that we've got here, it says that if we read the spec, we follow that given, when, then protocol. So this whole test tests that we are including some event details when we log the changes. So when we destroy a product, we want to create a log of it so that, you know, if we ever need to go back to it, it's already there. So I create the service, which is, you know, the service destroy product.new, and I'm going to call that service, and I'm going to select the last event from the database. The issue with what we have right here right now is that it's only selecting based on the last event. And this is okay if you have a single threaded app, meaning like one thing happens and then the next thing happens and then the next thing happens. Like, it happens in absolute succession like that. But like we talked about, like, if you have something on the scale of Amazon, so to speak, right, and you're destroying a product, there could be like 10 million events happening a second or something like that, or every minute there could be like 10 million events happening. So how are you absolutely certain that this is the corresponding event to this destroyed product? We're going to change a little something here. We're going to add in an adder reader for event. And we're going to do @event equals event.create. So all I've done is I've created an additional instance variable, and so that I know that this destroy product has a particular event associated with it, and I can access that event with 100% certainty. Just do service.event here. And then I can verify, like, this particular event associated with this service actually has the correct user who deleted it, the event type, and the event details. Let's run this one more time. So we verified that this service works. Like we basically moved all the code over from the products controller spec into the destroy product spec. And we've deleted all the corresponding tests here. Now, when you go to this products controller and I look at the destroy action, again, I've tested that it's going to redirect back to the manufacturer's page. And I see that it's going to be calling out to the service. However, I don't really have a test here that basically says like the products controller is going to reach out to the service. And I need to test that type of information as well. So I'm going to add an additional test. And again, this is all found in your curriculum in case I'm going too quickly or it doesn't make a ton of sense. I'm going to add another test that basically says it invokes the destroy product service successfully, because that's all that this controller action is doing right now. It's calling out to the service and it's redirecting. I've tested that it's redirecting, but I have not tested that it's calling out to the service. So I have three things here. Basically, this is a new RSpec, I guess, format that we really haven't seen before. So it's saying allow destroy product, receive new, and call original. Basically saying like allow destroy product. Like, let's skip over this one. So this is the given. Like this is what I need in order to set up this test. The when is what's being executed when the test is actually being called. So when I say that, and this is the expected result. So expect destroy product to receive new with user, product ID, and manufacturer. So I'm just making sure that the destroy product actually is called and it receives these three parameters. That's all this is doing. It's just saying like I'm calling this extra class correctly with the correct information. Let's run the test. Let's see if this works. Cool. Everything still functions. We're going to go down one more rabbit hole of like one last refactor. So if you take a look inside of our destroy product service object, it's kind of weird. Because it gets passed in a product ID. So the current user is an entire database object, right? Because that's something that Devise gives us for free. It passes in a product ID, which is a number, and then it passes in the entire manufacturer object. And that's kind of something I want to avoid. I don't want, again, that's the whole reason why we went down this rabbit hole in the first place. The whole reason why we went down this rabbit hole in the first place of like having service objects here is because one controller knew way too much about everything else. And similarly here, if I'm passing in the entire object from the controller down into like a service object, it's just, you're getting into the point where you're coupling once again. Let's make one small change here. So we're going to change this from the entire manufacturer to just do manufacturer ID. And from here, I'm going to pass in, I'm going to do manufacturer menu. And then let's run the test one more time. And by coincidence, this code is going to still pass all of our existing tests. Let's see. You are passing an instance of active record base to find. Please pass the ID by calling the .id. Okay, so we will. That's pretty simple. The warning over here is basically saying you are passing an entire object rather than passing just an ID. And the reason why we have manufacturer is because we have this before action for find manufacturer. So before any action is taken inside in the products controller, I'm going to find the manufacturer, which is going to be down here. So I'm going to say, remember when we were doing like only for certain like controller actions are we supposed to execute this code? There's an opposite version of that, which is except. So it's basically before every single action, find the manufacturer except for this destroy action. So instead of passing the entire thing down here, I am going to just do params of manufacturer D. Let's see if this passes our tests. I blew up something. Let's see. Redirect to manufacturer path. Looks like manufacturer ID. Go back here, jump into this. Which test is this broken on? Products controller spec RB 254. Manufacturer. Arguments expected 0, good 1. No. All right. So I just kind of want to recap service objects. Again, this is one of those, this is not one of those like absolutely needed things inside of Rails. This is just one of those like, if you want to impress a future employer or like during like an interview, or if you want to just try this out on your own, it's definitely something that you want to start putting inside of your code, but it's not an absolute necessity. If you take a look inside of, if you really want to, you can go with that, like really the fat controllers and skinny models, or you could go with fat models and skinny controllers as well. But I'm just saying this is another way to organize the code that you already have. Instead of putting everything inside the controllers or everything inside the models, separate one of those things out into the into service objects. Create its own class like that does one thing. Like email users, like that should just be the name of your service object, and you can just do .call on that inside of your controller rather than having all the logic inside of your controller action. Alex?
Seems kind of like mincing words, because when you create a new instance of it anyway, basically importing all that code into your controller, so it's still like a fat controller, but it just looks pretty, which is...
That is, I see what you're saying. That's not how it runs.
Mm-hmm.
Basically, yeah, that's not how it runs, because this is an entirely separate class,
Mm-hmm.
and the separate class takes care of its own like call method.
Mm-hmm.
So it's not technically it's not like this. It's not like I'm copying and pasting everything from here and dumping it inside the controller.
Mm-hmm.
I'm literally delegating this task out to the destroy product.
Does this speed up the program, do anything, just clean code?
It's just clean code. You can kind of imagine if we were to destroy things and have 6 extra things to do,
Mm-hmm.
like this method might be 100 lines long, and then you have to read through every single thing.
Mm-hmm.
It's similar to say like when we were doing things inside of Sinatra, we were unorganized with our code. We just threw everything in one giant thing. It's fine, it'll work, but it's hard to read at a certain point. So that's why we have individual folders with individual like tasks to do.
How would you put this into the module?
How would I put this inside the module?
The model, sorry.
How would I put this inside the model?
Yeah. How would you make it a fat model scheme?
Okay, so if I were to destroy the product, so I would, essentially what I would have to do is I would throw this inside of here and create its own method called delete and create event. I can write it directly on here, and then essentially what I'm going to do is copy and paste all of this code directly inside of here. There's a few things I probably won't need. It probably needs to know about current user, product ID. Actually, it knows about itself. Product ID, manufacturer ID. It'll look a little something like this. It's kind of goofy looking. Probably look a little something like this, and then instead of doing it here, I just do like product.delete and create event. Something like that.
Mm.
But the issue with this then is like your model knows so much stuff. You know, like this particular model knows about the current user, knows about the manufacturer, knows about event, and knows it needs to destroy itself, and then it knows it needs to create an event. Like at this point, your product knows about 1, 2, 3 other classes. And it's a model is if you were to just go with the strict MVC model, a model is just supposed to connect with the database. That's about it. Just supposed to connect with the database and do basic CRUD operations. Just should not know about 4 other things. This thing is
in a model that's relevant to itself.
Mm-hmm.
So it's not like you would never see methods inside a product that isn't something, you know, double check the model's title or like make it look better or something like that. Like it could do model specific things, but if you're starting to expose other classes to it, that's extending its responsibility.
Yeah. Yeah, this destroy product only knows about what you pass in and only does what you're supposed to do. From here, if anybody was able to like get into your code base or something like that, I'm able to get to all of these different classes from here. Like this one is supposed to do it. So like when we were at Groupon, like anyone could technically go into the orders database, right, and like modify whatever they wanted. But there was because if you have that, then there's not one single point of failure. My team was authorized to go inside of the database and to alter things like actual live data. Like that's what we were allowed to do. We were given those permissions to do all of these things. Like the other teams are not. Other teams are not allowed to do it because there's a lot more liability there. So it's kind of the same concept here with this destroy product. You're given certain responsibilities and certain information, and you're supposed to do one thing. So that's essentially what a service object is. It takes all the business logic out of the controller or out of the model and puts it in its own class to execute.